MathCounts 2023 chapter level spring round, the last question 30. It says someone is drawing a line connecting the points. Each point is connected to exactly two other points. What's a probability that the picture drawn is a convex hexagon? First of all, we want to specify that the only possible convex hexagon is ABC, D, E, F. And there's no other way that we can draw a convex hexagon other than connecting these dots in such a way. Why? Because any other connections will make there's a cross. Therefore, we only need to know how many ways as a base that the 6 points could be connected. Apparently, we can do a full permutation of the 6 points, A66, and they represent different ways of connection. So A66, is that the final answer? The answer is no. It needs to be divided by 6 and divided by 2. Why? When we do a connection A, B, C, D, E, F, and then back to A, it's actually the same as the connection B, C, D, E, F, A, and then to B. Because where we start and where we finish does not matter as long as this order of we go through the 6 points are the same. So when the A factorial calculate the bottom these two cases as two different cases, they actually should be regarded as the two same cases. That's why we divide that by a 6. And we also need to divide that by a 2. The reason is because either we do that clockwise or counterclockwise does not matter. For the A factorial, it's regarding the A, B, C, D, E, F to A, the different as F to E to D to C to B to A and then to F. However, this case 1 and case 3 are essentially the same thing. So that's the number of hexagons we can draw. That's in total 60. Is that all? No. There's another possibility that when we connect the 6 points, we're not even connecting them into hexagons, but we're connecting them into triangles. For example, triangle AED and triangle BCF. Each one of them is connected to 2 other points exactly. These are not even hexagons. So what's the chance of what are the different ways of we producing these triangles? Well, let's start from point A. For any point, it has 5 options to connect with. For example, A has 5 options to connect. But once A has connected with one point, for example, with B, and then there are only 4 options left to connect with, which are B, C, and F, and D. And if we pick one, for example, B, then we get a triangle. Then the leftover 3 points has no choice but to connect with each other to form another triangle. However, we need to divide this by 2 because triangle AEB and triangle ABE are the same. So you first pick B and then you pick E, or you first pick E and then pick B, was counted as 2 different triangles, while they essentially were the same. So in total, we can form 70 different connections among those 6 points. Only one of them can make the hexagon convex, so the chance is 1/70th.